An architecture has been described as providing a framework in which to satisfy the requirements and serve as a basis for a design. So it makes sense that we should develop good ways of analyzing architectures to determine how well they carry out that purpose. Do they still satisfy the requirements? Might there be another way an architecture could do it better? If we have some options, which is the best one for us? The IEEE recommends using architecture descriptions as a basis for review, analysis, and evaluation of the system across its life cycle, and as a basis to analyze and evaluate alternative architectures. So how should we go about analyzing architectures? That's what I want to talk about today. Let's start by considering what an architecture is and how we describe it. We can think of an architecture as a set of architecturally significant decisions that come together to address a significant business requirement. These are not separate independent decisions, and together they are closely connected to each other and embedded inside each other. We can't simply address each one separately, combine the decisions, and consider the result to be the final architecture. In his book, A Pattern Language, Christopher Alexander describes how 253 design patterns form a web, connecting all the way from selection of items to hang on the walls of your living room, right up to the distribution of towns across a region. IT architecture is, in this respect, no different from real architecture. It is a kind of set of connected Russian dolls with related architectural elements linking together and themselves containing yet more architectural elements. And unfortunately, the requirements that make up the overall business requirement are, to a greater or lesser extent, in conflict with one another. To take a very simple example, the desire for a system to be easy to use might conflict with the desire to make it secure. There is no correct resolution of this conflict, as it depends on the context. One might choose one trade-off between the two for a banking application, but adopt a different solution for a simple information service that does not involve personal data. Many such conflicts might exist among the requirements of a system or service, and a preferred architecture can be seen as a solution that delivers value, but is nonetheless an inevitable compromise. Analysis of the architecture helps us to understand the nature of that compromise. Many of the architecturally significant requirements are expressions of desired quality attributes. Can we live with the limitations that the compromise represents? By how much will the value of the solution be reduced as a consequence of achieving reduced levels of some desirable quality attributes? Might there be ways of mitigating these deficiencies? Or might an alternative architecture, representing a different set of compromises, deliver greater value overall? We come then to a primary reason to analyze architectures: to compare alternatives and select a preferred architecture among them, having understood their relative strengths and weaknesses. And it makes sense to do this by analyzing candidate descriptions rather than going all the way to building a set of alternative solutions and then choosing among them. Existing systems tend to get amended over time. New features and capabilities are added. New demands, unthought of when they were first built, are placed upon them. So we come to another reason to analyze architecture: to look at an existing asset and consider how well its architecture is suited to today's requirements of it. Can it be improved? Should it be replaced? What are its strengths and weaknesses? Is it still fit for purpose? So we've got reasons to analyze architectures. How do we do it? To start, we need to create the context. Who is the architecture intended to serve, and what do they want from it? If we can articulate this, we can measure an existing or candidate architecture against the context to see how good a fit it is. Does it serve some stakeholders better than others? What are the weaknesses and can they be fixed? Let's look in more detail at creating the context. Identify the main stakeholders. We know how to do that. Build a stakeholder map and then pick out those who care most about this system. Now we need to identify what they want. As architects, we're interested in the architecturally significant requirements, or ASRs. Write them down and make a note of which stakeholders care about which ASRs. Sounds simple enough, but as the learning shot on requirements points out, the reality is not so simple. Take a look at it to find out more about ASRs. A quality model is a good way of organizing a workshop to identify the relevant quality attributes and describe them as an initial set of ASRs. You might, for example, use ISO 25010 as a starting point. But quality attributes are just a part of the story. They cover what some people like to call non-functional requirements. But there are functional ASRs too. I found capability models to be a good way to structure the identification and collection of functional ASRs. So now we have a good view of the direct ASRs, but what about the indirect ones? Perspective-based architecture method, or PBAM, adds perspectives such as IT and business environments and trends, and the structure it introduces can help you to complete the picture of architecturally significant requirements. There is probably no single answer as to how to best identify and document the ASRs. It depends on where the domain, requirements, and system knowledge lie. Is it in a few people or many? Can you get them together in a workshop? Or will you need to conduct interviews or send out a survey? Perhaps a desk review of documentation can get you most of the answers. At the end, your context should consist of a set of ASRs, each one classified according to a quality, capability, or perspective model, and a set of stakeholders with connections to the ASRs they most care about. Now we know what we want the system to do and who wants what from it. We have the context in which we will conduct our analysis. The analysis itself is best done in a workshop, ideally with a group of stakeholders as well as architects. One benefit of this approach is that the stakeholders often come out of it with a much better understanding of each other's perspectives than when they went in. And all tend to realize that there is no perfect solution out there. Anything real will involve compromise and trade-off because of those inherent conflicts and contradictions among the collection of requirements that make up the description of what everyone wants. Everyone needs a certain understanding of the architecture or architectures to be analyzed. Perhaps this can be done by correspondence in advance or in presentations at the beginning of the workshop. Next, work through the requirements and agree the extent to which the architecture or architectures can deliver them. Debate differences of opinion. Make note of smart ways to mitigate problems or alternative solutions to particular components. I've seen a workshop come up with a new architectural option on the day that appeared to be much better than the 3 candidates the team had spent ages developing ahead of the workshop. If you're using a tool like that for Solution Architecture Review Method, or SARM, you can capture finely grained information and it will show you the trade-offs at the abstracted level of the quality model automatically. It will let you drill into the detail where necessary and see the strengths and weaknesses of each architecture from the standpoint of different stakeholders. Be prepared for surprise. Although it is, in effect, a giant multidimensional mirror reflecting back what you've just told it, there is something magical about seeing the wood for the trees for the first time. Of course, it might simply confirm what you suspected, in which case you now have the evidence to back up your excellent judgment. But it might show you previously unseen problems or opportunities. Use the tool to explore, discuss, and uncover the story or stories that lie behind the numbers. If you're not using a tool, you can still follow a similar approach, but you'll have to do the abstraction as you go along. Stay at the level of the quality and capability model to avoid getting lost among the weeds, but dip into the ASRs to stay grounded in the practicalities of what is really wanted. You're looking to capture the architectural strengths and weaknesses of each solution, the inherent trade-offs that make up the inevitable compromise of a real architecture. And rather than just end the workshop when you've reached some conclusions, take time to discuss how you might mitigate some of the outstanding risks in each architecture. Think creatively. Perhaps you can circumvent a weakness with a change to people or processes. The answer doesn't always lie with more technology. I mentioned at the beginning about architecture looking like a Russian doll, a system of systems, or rather an architecture of architectures. At what level should you be using these architectural analysis techniques? There is a spectrum of decisions involved in your work as an architect, from the simple and straightforward, where your knowledge and experience, perhaps combined with established standards and patterns, will tell you the answer, to a whole business system where perhaps no one individual is qualified to judge every aspect of the architecture. If you need to document your decision, to explain it to others, or perhaps to see it more clearly yourself, then you should be conducting some form of analysis. At its simplest, it is no more than writing down a context and walking through the options, making notes as you go. Models, like a quality and capability model or PBAM, guide you to keep you honest and to make sure you are looking at it through 360 degrees. And if you want stronger evidence to back up your recommendations and decisions, then take a look at a more formal method like SAM and its accompanying analysis tool. We started this talk with the proposition that architecture analysis can determine how well an architecture meets its primary purpose, to provide a framework in which to satisfy the requirements and serve as a basis for the design. In looking at how to analyze architectures, we've uncovered a lot more benefits from doing this. We've brought together the system stakeholders, getting them all on the same page and helping them better understand each other's perspectives. We've set realistic expectations for what can be delivered. There is unlikely to be a perfect solution to a complex set of business requirements. A real solution will inevitably be a compromise of one sort or another. We've been able to anticipate the reaction of key stakeholders to different candidate architectures. We've gained a view of the strengths and weaknesses of each architecture we've analyzed, explored possible mitigations, and understood the risks we might be left having to manage. If we've used this to evaluate competitive bids in a procurement, we've injected the evaluation with architectural thinking and avoided a superficial beauty contest. And we've gathered evidence and arguments to support key architecturally significant decisions, demonstrating good governance to the likes of colleagues, executives, customers, directors, partners, and maybe regulators too. I've described architecture analysis as providing evidence. Neither a method nor its supporting tools can tell you what decisions you should make. These should remain in the hands of those who are accountable. Now, this should appeal to the architect as communicator and storyteller. Behind every analysis lies at least one story, and it is your job to find it and tell it in ways that won't just convince fellow architects and engineers, but all of your stakeholders. I'll finish with what I think is perhaps the most important thing to bear in mind when conducting architectural analysis. The right architecture is not necessarily the one with the best score. It is likely to be the one that exhibits the most elegance and beauty, and whose residual risks can be most easily mitigated. Around 25 AD, Marcus Vitruvius Pollio, in his treatise De Architectura, included beauty among his three architectural universes, along with utility and firmness. And on the 1st of March 1999, In his keynote address to the ACM Symposium on Applied Computing in San Antonio, Edgar Dijkstra said, "After more than 45 years in the field, I am still convinced that in computing, elegance is not a dispensable luxury, but a quality that decides between success and failure." You cannot outsource your accountability for making an architectural decision to the analysis or its tool. They exist to shine a light on architectures from many different angles so that you can more easily see both their beauty and their flaws. Architecture analysis won't make the decision for you, but it will give you that most powerful property, confidence.